So 27, this is just another application of similarity. We're given that all these transversals here are parallel. So that creates a series of three similar triangles here. So this small triangle is similar to this one, is similar to this one, similar to all these problems we've just been looking at. So what we're given here is this length is 16, MO, this entire length here is 28, PQ, which is this small length here, is 14, and we're asked to find this small length here. So maybe the first thing to do is, again, all these pieces are going to be proportionate because it's all similar pieces of similar triangles. So since they've given us the entire length here, I'm going to figure out what ON is. It's just 28 minus 16, so that has to be 12. 12 plus 16 is 28. And now we can just, because these are kind of in a way proportionate pieces, we can know that 12 turns into 14 and 16 turns into x. So we can solve that proportion. 12x equals 16 times 14. X equals 16 times 14 all over 12 to get it by itself. If you put that into your calculator, you will get about 56 thirds, which is 18.666 repeating. First question is, are these triangles similar? We have one congruent angle, so we can find one other congruent angle. We're in business. Yes, we have vertical angles here, so now we've found two congruent angles. So by AA, the triangles are similar. Similarity statement, we'll make sure we get this right. I'm going to go ahead and write this triple angle in here so we know which ones go with which. So we'll just, on the triangle on the left, we'll call it triangle ABE. Is similar to, this is the squiggle. Now we just got to get the right corresponding vertices. So this triple angle is A, that triple angle is C, this triple angle is B, I'm sorry, this single angle is B, this single angle is D, and then this double angle is E, and so that's our similarity statement. And now we just got to do corresponding pieces, make sure we get that right. The triple angle is shining at 6, this triple angle is shining at 4, so we know 6 turns into 4. This single angle is shining at 8. This single angle is shining at A, so 8 turns into A. 6A equals 32. A equals 32 over 6, which if I divide each of those by 2, you get 16 over 3. And that's the answer. Hey, what do you know? This is the exact thing we did outside in class. So this one hopefully will be easy for you. The key thing here is to see that we have two vertical angles. I'm sorry, two similar triangles. I'm not sure why I said vertical angles. Because this light ray creates the same angle bounce in and out. We have a right angle here, so we have two congruent angles, so they're similar by AA. And now we have corresponding pieces. What we actually want to find here is, I'll call it F, the height of the flagpole. Her eyes are 5 feet above the ground. So here we know that 12 turns into 48. 12 turns into 48. And 5 turns into the height of the flagpole. So 5 over F. Now we go ahead and cross multiply here. Actually, I'm just going to go ahead and do it. 12F equals 5 over 48. F equals 5 times 48 all over 12. You can see that 48 divided by 12 is 4. So I'll go ahead and turn that into 4. That's a 1. That's 5 times 4 equals 20. So this flagpole is 20 feet high. Looks like my page in my thing here is messed up, so I'm just going to draw this up here. So I'm doing problem 30, but I'm going to do it up above it. A telephone pole will cast a shadow 36 feet long. So here's our telephone pole. here's our shadow, 36 feet. And over here we have a guy who's 6 feet tall, and he casts an 8-foot shadow. And so here we have the sun creating the same angle here. That's the idea behind these shadow problems, is the sun is creating a situation where we have the same angle, and so we can use similar triangles to solve this problem. So this 8-foot shadow turns into a 36-foot shadow. So 8 turns into 36. So the 6-foot height of the man turns into the height of the flagpole under the scale factor. So that equals 6 over, or whatever this is, telephone pole. I'll call it P for the height of the pole. And then we'll solve this proportion. 8P equals 6 times 36. P equals 3 times 36 all over 8. Sorry, I could see myself getting stuck there, and I see you probably saw my problem. When I multiplied 36 times 6, I wrote 3 here for some reason, so that's 6. See, math teachers make mistakes too. This should be 6 here. So 6 times 36 divided by 8 equals 27, which is the answer. So the height of the flagpole is 27.